In example 7, we are looking for the critical numbers of this function. So what we're going to do is we're going to find the derivative of the function. We're going to set that derivative equal to 0, and we're going to solve for x. And those x's will be our critical numbers. So in order to find this derivative, you could use product rule because we have a variable times another variable. Or I think the easier thing to do would be to distribute that first. So it would be 4x to the 3/5 minus x. If we add exponents, this has an exponent of 1, which is 5/5. So if you add the exponents, you're going to get 8/5. And so I did not do a derivative yet. All I did was distribute this and make it a simpler function so that when I find my derivative, it's an easier process than using product rule. So I rewrote it, and now I'm going to find my first derivative. So I'm going to multiply 3/5 in front by the 4, and I get 12 over 5. And then I take 1 away from the exponent. 3/5 minus 1, which is 5/5, is going to give me negative 2/5. Minus, if I multiply 8/5 in front, get 8 over 5x. Then if I take 1 away, if I subtract 5/5, I'm going to get 3/5. So there is my derivative. Now here we want to try to simplify this derivative as much as we can so that it is easy to set it equal to 0. Right now I can go ahead and set it equal to 0, but it'd be a really difficult equation to solve. So what I'm going to work on is I'm going to get common denominators. Well, I'm going to rewrite these instead of negative exponents, and then I'm going to try to get common denominators. So what I've got is a 12 over 5 for the fraction. And then this x has a negative exponent, and so that's going to go to the bottom. So 12 over 5x to the 2/5. Minus, I've got 8/5. Well, they've got matching 5s, that's good. And this has a positive exponent, so it's on top with the 8. So that's what we have right now. And I want to get common denominators, so I'm going to multiply the bottom here by x to the 2/5 so the denominators match, which means I also need to do that to the top. And when you multiply variables of the same base, you add their exponents. So we're going to add 3/5 and 2/5 together, which is going to give me 5/5, which is an exponent of 1. So what that does is I have 12 minus 8 x to the first. 3/5 plus 2/5 is 5/5, which is 1. All over the common denominator, x to the 2/5. So that's what I have now. From there, it should be easy to set equal to 0. So I have my first derivative, put my notation in there, and I want to set it equal to 0. When I solve this, I can multiply the denominator to the other side. If I multiply all this by 0, it just will disappear, so it becomes 0. So now I got the denominator out of the way. And then I can solve for x. I can subtract 12, divide by 8. The negatives go away. 12 divided by 8. And that reduces by 4, so we would get 3/2. So 3/2 is a critical number. So critical numbers you find by doing first derivative equals 0. Whatever you get is a critical number. Also, critical numbers are anywhere where the derivative does not exist. So we have one critical number, I'm going to call that Cn. My other critical number is where the derivative, which is here, does not exist. And it does not exist wherever the denominator equals 0. And so in this case, I want to know what would make my denominator 0. If I divide by 5, I get 0. If I raise both sides to the 5/2, the reciprocal, I get x to the x equals 0. 0 to the 5/2 is 0. So 0 is my other critical number. So what I did here was I set the derivative equal to 0 to get this critical number. And then I set the denominator of the derivative equal to 0 to get that critical number.